if you only ever shoot video with one camera, then you really don't need complicated timing information. However, once you start using two-system audio or shooting with multiple cameras, then you have to start thinking about how you'll sync all of these sources in post-production. Now, you can, of course, do this manually by clapping or using a clapboard to create a sharp audio spike and a corresponding visual reference, but that is a tedious manual process to go through. In an effort to streamline things, most NLEs today can sync files automatically using their audio waveforms. Now, while this works when everything has a clean audio signal, it can fail in situations where there's too much background noise, or when the cameras are so widely separated that they don't have the same audio available. Professionals solve this problem using timecode or time codes, and if you've ever dug around in the menus on most Canon EOS R cameras, you've probably seen a timecode setting in there somewhere. So in this video, we're going to look at that, specifically some of the big picture stuff like what the timecode even is. We're also going to look at how Canon has implemented on the R5 and the R5 Mark II specifically, such as what menus and settings are, or where the menus are, what settings the menus have, and what those settings do. And finally, we'll talk a little bit about the limitation of Canon's implementation on these platforms and how that renders its utility or affects its utility. Now, as usual, each of these topics are separate chapters in this video, and you can skip ahead to whatever you're interested in simply by using the chapter markers and the timeline or the chapter list in the bottom of the video description. So to start off, let's tackle what timecode actually is and how it's supposed to work. Now, the short answer to this is that it's complicated. Well, it's not actually complicated. In fundamentals, it's really simple. The timecode creates a unique identifier for each frame across multiple cameras and media so that you can synchronize things based on those identifiers. Now, you could say that this is a time-based system since the identifier uses hours, minutes, seconds, and frame numbers as the referential units. However, those hours, minutes, and seconds don't actually have to correspond to the current time and your location, and in some cases may not even correspond or run at the same speed as the wall clock time does either. While this isn't complex in theory, it's the implementation details of how timecode works and has to work around a number of problems that really causes the potential issues in understanding. To start with, you need to understand there are many different timecode implementations. They all do the same thing, essentially, but they just are implemented differently. So you may have heard of LTC, or longitudinal timecode. And this is really just a specifically modulated audio waveform that you can feed into your camera's mic port or into a special input jack, and your camera or audio recorder will interpret this as a timecode signal. Now, HDMI and SDI, the video connections, can both provide timecode information as well, but in this case, it's done as digital metadata. It's not an audio track, and it's not the LTC signal. Even here, though, the technical differences or details are completely different between the two different formats. Since SDI is a broadcast video interconnect, the timecode system was built in as a fundamental part of its signaling standards. Though the implementation here is straight digital data, it's not encoded as an audio waveform the way LTC is. However, the consumer interconnect, HDMI, the one that our cameras use most of the time, doesn't actually include a timecode signal in the standard. Instead, camera manufacturers like Canon, Sony, Nikon, etc. transmit timecode information in separate auxiliary data packets or other info frames. This in turn means that HDMI timecode compatibility depends on the manufacturer of both the camera and the recording or receiving device. Now finally, Timecode information can also be embedded in most video formats, regardless of the compression algorithm that's used. Canon cameras use this functionality to embed timecode information as a separate data stream in all of their video files. Now, the other problem that faces timecode users has to do with the way NTSC frame rates were shifted down by 0.1% when color television or color was added to the signal in the 1950s. This shift is what produces the 23.976 or 29.97 frame per second frequencies that you see on NTSC cameras instead of the even 24 or 30 frames per second that you would expect. This 0.1% shift means that for every minute of recorded footage at 30 frames per second, the camera actually records just under 2 fewer frames than it actually should. 1,798.2 frames specifically instead of 1,800. Now, since the timecode increments by frame, not by time, this means that for a 30 frame per second recording, the timecode will deviate from wall clock time by 2 frames, or around 60 milliseconds per minute. It's also this drop frame situation why I consider timecodes to be frame identifiers and not time information specifically. Okay, with the theory out of the way, let's talk about what's available for the timecode on the R5 and R5 Mark II and how we can manipulate it. To start with, you will find the timecode settings on page 8 of the red shooting menu section, and this applies to both cameras and obviously when they're in video mode. On entering the timecode menu, you will find 5 or 6 options to choose from depending on the camera's currently set frame rate. Now, the first of these options is Count Up. Count Up controls how the timecode advances, and the options you have here are either Rec Run or Record Run and Free Run. Record Run only advances the timecode when the camera is actually recording. This is the default setting, and in essence, it turns the timecode into little more than a fancy recording counter. Free Run, on the other hand, uses the camera's internal real-time clock, or RTC, to continuously increment the timecode when the camera is on, regardless of whether the camera is recording or not. Free Run is what you would use if you were jam syncing multiple cameras using their internal clocks instead of some kind of external timecode box or system. Now, the problem on these cameras when it comes to this is actually syncing the multiple cameras. To use timecode effectively as a synchronization tool, it needs to be accurate to within a few frames, and ideally really the same frame. At 30 frames per second, that means you need to have your timecodes within 33 milliseconds of each other, and this is something you're not really going to be able to do by hand. Now, the next part of the timecode menu is the start time setting. Here you'll find 3 sub-options: manual input, reset, and set to camera time. Manual input allows you to set the specific timecode, including the hours, minutes, seconds, and frame number for the camera to start on. Reset resets the camera's timecode to 0 hours, 0 minutes, 0 seconds, and 0 frames. Finally, set to camera time. This sets the camera's timecode to the hours, minutes, and seconds that match the camera's internal clock. However, the frame number will be set to 0, regardless of where that time falls in the second. Now, the next 2 settings in the timecode menu control how the camera displays time in either recording or playback modes. Movie Rec Count controls what time information the camera displays in live view and when recording. When set to rec time, which is the default, the camera displays the time in minutes and seconds, counting up from 0 when the camera starts recording. In fact, it doesn't display timecode at all, it's just a recording counter. When this is set to timecode, then the camera will display the timecode with the frame number excluded instead of a record counter going up. Now, given the R5 has a 30-minute record limit, I found that the record time setting is more useful for me since it always counts up from 0, and therefore I can tell how long I've been recording and how long I have left until I run into that minute. In fact, even on the R5 Mark II, I find it much more useful to use record time than time code, since I can actually see how long I've been recording instead of what amounts to an essentially arbitrary number. Now, the second display related to control or counting control is movie play count. And this controls the timing information that's displayed when you play back a movie. Like movie record count, the options are either record time or time code, and they function identically to their recording counterparts, either displaying a counter that counts up from 0 as the movie plays, or the time code that was embedded in the movie file. Now, the last entry in this menu that's always visible is HDMI, and this controls how timecode and remote record start signals are set over the HDMI connection to an external recorder. In this menu, you will find two options, timecode and record command, although if timecode is disabled, you won't see record command either. The timecode option gives you the ability to enable or disable HDMI timecode transmission. When enabled, timecode information is added to the HDMI output at all times when the live view signal is active, not just when recording. However, timecode information is not sent when the camera is in the menus or in playback mode, even if your timecode is set to free run and the internal timecode is still incrementing. Consequently, if you have the camera set to free run and an external recorder like this Ninja Ultra set to trigger on timecode, the recorder will always record unless the camera is in a menu or playback screen. Now, when HDMI timecode is enabled, a second option, record command, is also available. Record command controls whether the camera sends a record, start, or stop command over the HDMI signal to signal the start and stop of recording. Now again, this is something that's not part of the HDMI standard, and its functionality depends on both the camera and recorder supporting the same start-stop protocol. In the case of Canon cameras, I know for sure that Atomos branded recorders are compatible and will support this, but I can't speak personally for anything else. Now, if enabled, a start command is sent when the camera starts recording, and a second stop command is sent when it stops recording. Now, the second stop command happens regardless of whether the camera or whether the recording was stopped by your own action, that is, pressing the record button again, or if the camera reached its record limit or thermal limits and stopped recording automatically. Now, the final option you may find in the timecode menu is the drop frame setting. And this setting is only visible when the camera's system mode is set to NTSC and the recording frame rate is set to either 30 or 60 frames per second. Well, technically 29.97 and 59.94 frames per second. But it won't be visible at either 24 or 23.976 frames per second. Drop frame was created to compensate for the 1% slower than expected NTSC frame rates and to keep the time code in sync with real time instead of having it drift. When drop frame is enabled, the timecode skips the first 2 frame IDs at the start of every minute, except when the minute is a multiple of 10. Otherwise, when drop frame is not enabled, including when it's not available, such as in PAL 25 and 50 frame per second recordings, or as I said, the 24 frame per second NTSC options, the timecode is incremented with every frame. Now, when drop frame is enabled, Canon indicates this by replacing the colon after the seconds period in the display where you would normally see the timecode with a period. Unfortunately, or for whatever reason, they don't use the normal semicolon that the rest of the industry uses to indicate drop frame, so something to be aware of. Now, this just leaves us with one question when it comes to drop frame. How should we configure it? The drop frame situation is actually why I call timecodes a frame index instead of a time, even though it's very clear the original intention was for it to be treated as a time. The reality is that either drop or non-drop modes can be used as long as you're consistent across all of your devices. Personally, I don't use drop frame, mostly because I shoot at 24 frames per second where it's not available. Now that does mean that my time codes aren't wall clock correct or real time, but for the purposes of synchronizing multiple cameras or recorders, it really doesn't matter as long as they use the same count and increment. Now, that said, in any case where you're providing content to another party, especially in higher end situations, you want to double check if they want the clips in drop or non-drop format, or if they even care. So, those are the timecode functions on the R5 and R5 Mark II. And in fact, basically nothing has changed between the two cameras, which I think is a bit unfortunate. The real problem with the whole system here is that it's kind of useless for anything other than pretending to be a serious tool. Today, at least with these cameras in this situation, timecode really serves one function for most of us, and that's accurate synchronization with other cameras and audio tracks. And for that to work, you need to be able to synchronize all of your cameras to the same timecode accurately, like down to the frame. Now, while this isn't an intractable problem for modern technology, it actually would be really simple, it's not something that Canon clearly intended for their hybrid cameras to be capable of doing either. There are certain things in the menus that kind of imply that maybe that they could do something like this, but when you actually get into the details, it just doesn't quite work. Yes, you can, for example, set the time code using the camera's clock. And you can, of course, set the camera's clock using either your smartphone or a computer as a reference. So in theory, all your cameras could have the same time, and they could all set the time code from that time. However, Canon doesn't guarantee that this will result in an error of less than plus or minus 16 milliseconds. And in fact, in my testing and trying to set both my R5 and R5 Mark II to the same time and time code, etc., my results using just my laptop as a clock source resulted in multi-second errors in the clock. Further, when setting the time code from the camera's time, the camera always sets the time code's frame number to 0, regardless of where in the second you actually are. This means that even if you synced the clocks between two cameras or more perfectly, you can still be off by as many frames as there are in a second, simply based on where in that second, I should say, the time code setting actually picked up. And in the end, it's this limitation that makes the timecode system on the R series cameras really nothing more than a fancy frame counter and not the super effective tool that it really should, or at least could, be. That said, I hope you found this useful, or at least interesting. If you did, let me know by hitting that like button. Also, if this kind of thing seems like it might be your kind of thing, please consider subscribing if you haven't already. Finally, if you'd like to help and support this channel, you can help us for free by liking this video, sharing it with your friends, and leaving a comment with your experiences. Likewise, you can support us by hitting that thanks button or buying yourself something you've always wanted from one of the affiliate links in the description below. And as always, thanks for watching, and I'll see you next time.